Well, welcome back, everybody. This is the lecture for part 3 of the solar system chapter. You'll see it's a relatively long chapter. That's why we're breaking it up into so many pieces. But let me just remind everybody about the writing assignment. Okay, it's due next Thursday, the 23rd of April. I'd like you to please send it to me before the end of class. Whatever your class time is before the end of class, that's the absolute deadline. There will be nothing accepted afterwards. Please do not ask me that you want to hand in a paper. My dog ate it, whatever happened, please. You have plenty of time. Do it early. Email it to me, all right? And then also follow the directions I sent you on Blackboard and on the discussion forum. I have them posted in both places of how to title your paper when you send it to me. The name of the file with your name, your section number, and then WA2, meaning writing assignment 2. But just take a look. I have it in that area in the discussion forum. So if you can just look at the link down below, you watch this video. It's very interesting, in fact, called Asteroid, Doomsday or Payday. And it's about 45 minutes. And it kind of tells us what we can do if an asteroid is approaching Earth. What are some of the things that we've already seen, and what are some of the things we can do? The link down there is below. It's on YouTube. Try not to click on it, as I've told you before. Just cut and paste it into your browser. Okay, let's continue on our discussion of the solar system. The next topic I want to talk about, when we talk about objects from space, there are three general top categories, if you will, or definitions that we probably should be aware of. One is an asteroid. What's an asteroid? Well, asteroids are generally large chunks of rock or rocks and metals, or combinations of both, right, that come from the asteroid belt that are located between the orbits of Mars and Jupiter. I told you that's where the asteroid belt resides, and an asteroid is any piece that comes from that. All right, then what's the difference between then an asteroid and a meteor? A meteor, that's the flash of light that we see in the sky when a meteor comes into the atmosphere and burns up. You'll see a photograph of one that I took, in fact, right here. Here's a photograph, it's a small time exposure, of a meteor exploding overhead as I was photographing the sky. In fact, the way I took this picture is I was in an area out in Peconic, Long Island, during the time of a meteor shower, and I wanted to be able to photograph meteors coming in. And as soon as I opened the camera and pointed it towards the sky, I just had the shutter open. All of a sudden I saw a bright flash. It lit up the whole area. I looked up in the sky, and thank God my camera was pointing to where the object had burned up, and it was directly overhead. You can see in the photograph here, you can see this little brownish material here. That's actually a smoke trail. This object, typically I told you, when objects come in from outer space, they're traveling very fast. And as they hit our atmosphere, then they rub against the air molecules and cause heating, just like from friction. Just like when you rub your hands together, as I told you before. When you rub your hands together, they heat up due to friction. What happens is, as it passes through the atmosphere, this piece of debris will glow and heat up tremendously. And if it's loosely held together, it may completely burn up. Okay, and at that point we call it a shooting star. The way that is, a shooting star. A lot of people call it that, and that's a meteor. However, if it doesn't completely burn up in the atmosphere and it makes it to the ground and it lands on the ground, we call it a meteorite. Okay, and the meteorite is the part that survives that fall through the atmosphere. Okay, typically the shooting stars that you see, if you've seen any, I know a lot of people, I always ask, have you seen a shooting star? Some people do, some people haven't, but seen it. But if you have, it's just a streak of light that occurs very briefly up in the sky. Usually those shooting stars are the size of grains of sand, of particles that are really, really small. And of course, they're going to completely burn up when they come through the atmosphere. However, if a meteor is larger and not held together very well, it'll be larger. It could burn up in the atmosphere. However, perhaps if it's made of metals and things mixed in with the rock, the metals may not disintegrate as much as rock will, and it could reach the ground. And that's what we call a meteorite. So those are the definitions, if you will, some definitions to remember. An asteroid, a meteor, and a meteorite. And you can see also here's another daytime meteor that appeared in the sky. You can see here it left a smoke trail during the daytime. This is one that recently fell in Russia in a town called Chelyabinsk. We're going to talk about that in just a moment, but I wanted to make sure that you understand the differences between these topics. One, what is an asteroid? Okay. What is a meteor? A meteor is the shooting star, and a meteorite is the result of a meteor not burning up completely in the atmosphere and then reaching the ground. We can see here that the Earth has been hit by several meteors in the past, or meteorites, let's say. And here is some of the recent. Some of the evidence of that. And here's on the left-hand side, as you can see right here. This is an area in Arizona, and it's a meteor crater from a meteor that hit about 50,000 years ago. This is the crater that it left in the desert. Okay, and you can see here there's a little road that you can go over to the edge of the crater, and I believe, and I'm not sure, I think at the bottom of the crater you can somehow you can go down this road. It may be a windy road that winds up here at the bottom, and then you can actually go to a museum and you can buy t-shirts and things like, stuff like that. But it's interesting that here's a 50,000-year-old hole that was blown in the earth from an explosion of a impact of an asteroid with the Earth. Okay, that was 50,000 years ago. Here's another one on the right-hand side here. This one, you can see there's a lot of green growth over it. This one is around 120,000 years old. Okay, it's called Wolf Creek Crater, and it exists in Australia. It's almost a kilometer in diameter. Both of these are just about a kilometer in diameter. And this was a rock that hit the Earth, and you can see also craters like this. You see some craters on Earth, but certainly if you look at the moon, you see so many more craters. Now the question is, well, why do I see so many craters on the moon and I don't see that many craters on the Earth? Well, if you think about that for a moment, you'll see that the moon does not have an atmosphere. So whatever hits the moon and puts a hole in the moon is going to remain there for hundreds of thousands and millions and perhaps even billions of years, because there's nothing to change it. Nothing going to change and smooth out that crater. However, if one of these asteroids hits the Earth and creates a crater, well, since we have an atmosphere, we have weather conditions, and we have wind, and we have rain, and environmental factors tend to erase a lot of the craters that we have on the Earth. They could be also some at the bottom of oceans and completely washed away by water. Some of the remnants may be there, and as we said before, you can see the remnant of the crater impact that killed all the dinosaurs was at the bottom of an ocean, but it wasn't very clear to see. They just had to look that the density of the rock was compressed in certain areas. So it took special instrumentation to try to measure that. However, it's more difficult to find craters on the Earth because of the environmental effects of weather and wind and rain and things. On the moon, that doesn't happen. So we should have as many craters on the Earth as there are as the moon. The way the moon looks all scarred and everything, the Earth should be just as bad. But as I told you, it's the weathering effects that erased most of the evidence on the Earth. Here's another crater here. You can see almost like a perfect circle. This is an area in Quebec, Canada, called the Manicouagan Reservoir. As you can see here, it looks like an area that's been filled in by water. It was probably a low area from the hole that it left in the earth. And as the glaciers came down over the glacial periods during the ice ages, water melted and retained and stayed in there, forming like a little lake and a reservoir in there. That's another example of a crater on the earth. But as I told you, it's the environmental effects that erase that evidence from the earth. Meteorites always hit the earth. The earth is always being bombarded by meteors of all sizes. It's the big ones that cause the damage. Here's one. Here's just a photograph of an object that was landed in the desert in Africa called the Nubian Desert. In 2008, people had witnessed a large flash in the sky, and this object was, I guess, big enough that it didn't burn up completely in the atmosphere and landed on the ground. And one of astronomer here, or a geologist, actually found it laying in the desert, right on the desert floor. And sometimes that's how you can find a lot of these meteorites. Okay, this is a meteorite, right? Because it has struck the earth. It was a meteor. The shooting star was in the sky. That was that streak of light called a meteor, and the meteorite is here on the earth. So this is how sometimes we find some of these. I want to talk about here some of the impacts of some of the objects from space with the earth. All right, and one of the largest events, okay, in recorded history means since we've been keeping records, okay, was in Tunguska, Siberia in Russia on June 30th of 1908. And as you can see here, here's a map of Russia. The Tunguska area is in Siberia. It's right around over here. You can see the Tunguska vent. It's marked by that red line. This is an area in the middle of a marshland, of a wasteland, cold and wet and dry and ugly, and not many people live there at all. But this is a very large area in eastern Russia called Siberia. And an object there was reported by the scant people that lived in that area to light up the sky, okay, and it knocked down trees for over 800 square miles. Okay, you can see here's a photograph taken back in the early 1900s via an expedition that was sent to that area in Siberia, because almost nobody lived there, but the reports of some neighboring town people that had seen some and heard a large explosion witnessed the fact, and this was 10 years later, they had sent an expedition there, found these trees that are completely leveled, fell down like matchsticks. All right. And from the extent of the explosion there, scientists have been able to determine that this was about 1,000 times more powerful than the atomic bomb that was dropped on Hiroshima that contributed to the end of World War II. So these are very, very powerful events. And in fact, when you watch the video, if you haven't seen it already, the video on the asteroids, Doomsday or Payday, they actually show a small clip of the Tunguska, Siberia event. Okay? The scientists think that this was either a meteorite or maybe a small comet that may have exploded in the atmosphere about 3 to 6 miles above the surface. It looks like it completely disintegrated because there was no crater found on Earth and no pieces left from this. Nobody ever found any pieces of that meteorite, so we think it completely vaporized in the atmosphere, but the explosion from it coming in, that shock wave, was enough to knock down trees for over 800 square miles. And as I said before, this was the largest impact event on Earth in recorded history since we've been keeping records. So this was a little over 100 years ago. Most recently also, here's another one. Coincidentally, again, in an area called Chelyabinsk Oblast in Russia on February 15th of 2013, only 7 years ago. Okay, coincidentally, here again, here's that same map of Russia. Here was the Tunguska event. About 1,200 miles west is this a city called Chelyabinsk. And in Chelyabinsk, a meteor, another meteor strike, had been reported. And as you can see here, here is an image from one of those dash cams that a lot of people have in their cars. In Russia, apparently, insurance regulations are so strict that in order to get paid from accidents and everything, people bring evidence of recording of their driving, and they have these dash cams there, and a lot of people, most of the population has that to prove what happened during an accident. And many of these dash cams reported seeing this object coming in, exploding in the morning sky. This happened on February 15th. They think it was a meteor about the size of about 56 feet and had a mass of about 10,000 tons that struck the earth and struck that area in Siberia. You can see here it is. You can see the smoke trail left by that burning piece of debris. That explosion caused a shock wave that actually blew down some buildings and broke a lot of glass. You can see here, shattered glass in windows. It's interesting, one of my students several years ago was a Russian woman who was born in Chelyabinsk, and she had said that during this event some friends of hers had gotten hurt from flying glass that had exploded while they were working in certain factories and in certain offices there when that explosion occurred. It did not explode in the city. It went outside the city. And I have a couple of videos that talk about this event because it was widely covered by the news and in dash cams, as you'll see. And let me show you some of those videos right now. Here's one. So as you can see, a lot of this stuff was recorded now by that one right here. Here's a video. I'll click on it in just a moment to show you. It has some sound. It has people speaking Russian. And in fact, if you listen carefully, I had one of my students last year. He knew Russian, and it was translating some of the words that the people were saying, and they saw this smoke trail from this meteor that had come into the atmosphere during the daytime. This was around 9 o'clock in the morning. And you'll see him say something about Putin, and that maybe Putin is testing a new kind of missile or something, is what they were saying. But let's watch this video here.
И сгорел там, да? Ну.
А что думаешь, может спутник там уже же падал, а не
You could see the force of the explosion. My God. Now this one you saw before. This is just a different compendium or collection of videos they put all together. As soon as the explosion occurred, it broke a lot of glass. A lot of people were hurt from flying glass.
Ну что, ребята, счастливого, счастья,
Цифра 2823.
Это обращение в нашу справочную службу, которые зафиксированы за январь месяц.
Где-то.
I think the girl's taking a job interview, thinking that, I don't know what just happened, but I'm going to get out of here. So interesting. That was a bunch of cell phone videos and everything that people had taken. I thought it was a little interesting. Let's also look at, it turns out that a few weeks later, scientists had found that what remained of the asteroid, the meteor that went through the atmosphere, what remained after burning, a lot of it burned up, it actually struck a lake nearby. And this is just a video clip of them recovering the object from the bottom of a lake. I'll show you this in a moment.
From a far corner of space, this is a huge fragment of the meteorite that exploded over Russia in February. Divers worked in zero visibility conditions to retrieve it from the bottom of a lake. It's believed to be the largest piece of space rock to hit the Earth when a meteor broke up over the towns of Chelyabinsk, Yekaterinburg and Tyumen. If it's more than 500 kilograms, then the object is unique in itself, one of the biggest meteors in its class, i.e. the stone type. After it's been studied and analysed, its long journey will likely end on display in the Regional Nature and History Museum. The force of the shockwave when it hit Earth was estimated to be as strong as 20 Hiroshima atomic bombs. More than 1,600 people were injured by the effects of its landing. Thousands more watched in awe as the meteor exploded before their eyes, falling to Earth in a shower of light.
So yeah, that was the report of, that was the meteorite as it was found a bit later. And so, interesting enough, we see sometimes a lot of movies that are about these events where asteroids can hit the Earth, and that is a real possibility. Okay, and you'll see that from the video if you haven't watched it yet. It's a very interesting video. I hope it gives you a little encouragement to try to look at it a little earlier, that video that I told you if you do for your writing assignment. That's a pretty interesting one, and write your paper on it. And do it early. Please try to do it as early as you can. All right, let's change the subject now from meteors. Let's talk about other matter, interplanetary matter. One, we talked about asteroids and the possibility of asteroids crossing the orbit with the Earth and impacting the Earth, and I showed you evidence of that. Also want to talk about these other bodies called comets. And as I told you, comets are frozen bodies in the outskirts of the solar system, beyond the orbit of the furthest planet, Neptune. And since they're so far from the sun, these objects are completely frozen. It's typical remnants of frozen gases like carbon dioxide, nitrogen. There's even water. Okay, we sometimes called these comets dirty snowballs, if you remember. We talked about it before, that they're mostly ice mixed in with a little dirt. Okay, and as comets out in the outer solar system, if they collide with one another, or the passing of a large planet, the gravity of that planet could maybe attract some to come into an orbit around the sun, and if they survive the heat from coming in closer to the sun, because remember, they're frozen, they're a little over 400 degrees below zero out at the orbit of Neptune, and as they come in towards the sun, they warm up and they start to melt, and the debris that remains in their path we see as a tail of the comet. And here's some pictures, two of these here on the left. This one here is a couple of pictures of a comet that I've taken. One of these is called Comet Hyakutake, and comets are usually named after their discoverers. So this was a gentleman, an amateur astronomer in Japan by the name of Hyakutake, and he had discovered this comet, and as it came closer and closer to the Earth, you can see it had a pretty big tail. Okay, I took this picture. This was, I believe, in 1996. I took it out east, right where I took a picture of that other meteorite that had fallen. It was at a Girl Scout camp that's out in Peconic, New York. It's pretty dark out there, so that's why I'd gone out to photograph it. Here's another one I've photographed just from my backyard. It's called Comet Lovejoy, okay? And it was taken by, it was discovered by a man named Terry Lovejoy, an astronomer that looks in the sky every night, looking, hopefully trying to discover a comet to get it named after him. And these people have to get a life, to sit there all day and just look for comets. But here's some photographs you can see of the large tail that's behind the comet that could be thousands of miles long. And as I told you, comets contain four basic parts. Here's the four basic parts of a comet. One is the frozen core of that comet, that little frozen core right in the middle here. We call that the nucleus of the comet. That's that frozen body that resides out in space. And if that body would be attracted to the sun for whatever reason, due to a gravity event, pulling of gravity, or the collision with another object, and if it comes careening in towards the sun, as it warms up, it starts forming an atmosphere around that nucleus. That nucleus typically is only between maybe 1 and could be as large as 10 miles in diameter. They are not very, very big. These comets are not very large. The nucleus is only from 1 to 10 miles in diameter. However, when it heats up, this atmosphere surrounding the comet is called the coma. The coma of the comet. The coma could be 50 to 60,000 miles in diameter. It could be tremendously large. And that's what you see here in the photograph. You can't see the small nucleus of the comet. You're seeing the coma as it's entering close to the sun, and the material is forming an atmosphere. It's melting around the comet, and the gases are forming a large atmosphere. Okay? And there's also the tail of the comet. So the first, as I told you, one of the first components is the nucleus, and that's that small little piece in the center. There's the coma, and this is only formed after it warms up, and it develops an atmosphere from the gases that are melting. And then the material that is left behind, that falls off the comet, that's left behind, forms the tail of the comet. And there's two different types of tails. Is what we call a dust tail. Here you can see this is a picture of a comet. This is not one that I took, but this is called Comet Hale-Bopp. I believe this was around 1998 or a little later. This was a fairly bright comet. I remember seeing it, and I didn't photograph it at the time, but you could drive home from work, I remember, and I was looking up in the sky, and you can see this comet. It was pretty bright in the nighttime sky, but it was probably around before a lot of you were born. But it had a dust tail, and the dust tail is precisely that. It's dust that's melted and coming off the comet and leaving a path of debris in its path as it travels towards the sun. So it leaves it in its path. The other type of tail is called an ion tail. And ion tails are typically made from ions. What are ions? Ions are atoms that had their electrons stripped off. And what happens is, as sunlight hits the material on the comet nucleus, okay, it blasts off some of the electrons, and then you get a bunch of charged particles. Once electrons come off, the atom becomes charged. And then you have a charged particle tail called an ion tail. And sometimes it's visible. It's usually visible as a blue streak right here coming out of the comet. A lot of times it's more difficult to see. You usually mostly see the dust tail. And in fact, in this picture right here, in this picture that I've taken, those are the dust tails of the comet. So those are the four basic components that you probably should remember. One is the nucleus, and as I told you, that's the core that can be anywhere up to around 10 miles in diameter. And then the part that forms the large atmosphere of the material coming off the comet is called the coma, that completely surrounds the head, and that can be as much as 50,000 miles in diameter. And then the two types of tails are the dust and the ion tails. And of course, since I want to show you pictures here, I'll show you pictures of other kind of comets. And there was a very famous comet we're going to talk about in just a moment, called Halley's Comet. I don't know if a lot of you have heard of that, but Halley's Comet is depicted into this tapestry called the Bayeux Tapestry. And this tapestry was made around 1000 AD, and it depicted the war, okay, it was the Norman conquest of England, okay, where the Duke of Normandy and the Earl of Wessex, okay, who became King of England, they were culminated in this. This is supposedly part of the Battle of Hastings. It was a large tapestry, 224 feet long, okay, and 20 inches high. But you can see right here, I'll show you right, I've circled it in red here to show you they've actually indicated that it looks like a comet appeared during this battle, okay, and they depicted there the comet. You can see here they showed the head of the comet, and here's a tail of the comet. You can see this is back in 1000 AD roughly that they depicted comets. And comets typically have been omens of some sort of foreboding. People, when they didn't know what these comets were when they saw them in the sky. We only see them in the sky once they become bright and they come close to the Earth. Because I told you before, they're very small, and typically a lot of times some comets will completely disintegrate as they come close to the sun because they're not held together very well. Sometimes they will survive and they can orbit the sun for hundreds and hundreds of years. They'll be in a permanent orbit around the sun, just the way a planet could be, if there's enough material and if it's packed tightly enough that it survives. Sometimes they don't. I'll show you examples of both in just a moment. Here's some of the comet images that I've taken, okay? Other comets right here. Here is a comet called Comet Holmes, discovered by a man named Holmes. I don't know, this was back in, I can't read the date on there, 2007. And you can see this had not much of a tail, but looked like you could see the coma completely, the coma. That's that large atmosphere surrounding the comet. Look how much bigger. It's about as big as the full moon. It was bright in the sky, and it was around 2007. Here's another one in 2013, another one called Lovejoy, another comet Lovejoy, discovered by Terry Lovejoy. The green color you'll see is very prevalent in a comet. The green color comes from as sunlight strikes the comet, it emits, it melts the material, and the material that's there is the ice, and they're frozen carbon dioxide and nitrogen. And this green glow is a gas called cyanogen. It's CN. It's a combination of carbon and nitrogen. And this is actually a poisonous gas, okay? Poisonous. Cyanide, as you know, that's a type of a poison. This is a poisonous gas. That green color represents the color of cyanide. All right. You can see here's another one. it looks like it's got two tails. You'll see one coming out of this side, one coming out of this side. I think what the perspective of this comet is that it's coming right toward us, and we're looking down the barrel of the comet, if you will, and it looks like it may be a fan spread tail, and we're seeing a wide, I don't think there's two separate tails there. It looks like one big fan shape, but it's coming right at us. Okay, you can see a fan shaped tail right here. You can see another one. This was comet, well, Pan-STARRS. Pan-STARRS was some sort of a telescopic survey that found this comet. And this was a comet visible in the evening. Usually comets are visible when they get very close to the sun, and because that's when they get their warmest and they shed material. And they're usually visible closer to the sun. So the time of the day that we're going to see them is typically right before sunrise or right after sunset is probably the best time to see them. Okay, when the sun is up in the sky, if they're not bright enough, we won't see it. But you can see here's another comet. I believe this is the same comet, Pan-STARRS. I don't know if you can see it right here, and I have it here in the inset. This was right around sunset. I went down to one of the local beaches, and I had taken a picture right at sunset. The sun had already gone down, and you can see the comet right here. So interesting about some of these comet pictures. These are also, as I told you, part of interplanetary matter. Let's look at here. Most recently, okay, this is something pretty recent. Here's a comet that was coming close to the Earth just about this time of year. There was one I just photographed that I'd heard about it. It's called Comet Atlas. Atlas was another type of a special kind of telescope system that takes surveys of the sky, and accidentally found the comet. And I took a picture of it on March 27th, just a few weeks ago. And you can see here is the comet, and you can see a small tail coming out of the comet. And this was the distance this comet was. This was about at the orbit of Mars. And people had said that, gee, if this comet is so bright at the orbit of Mars, then when it comes closer to the sun, it's going to be huge, and it's also going to be probably visible during the daytime. And I was getting all excited. I wanted to get pictures of it and everything to be able to, tell you that you'll be able to see it in the daytime sky. But let me show you also, before I tell you what happened so far to Comet Atlas. Here's as I told you here's an image I took of it March 27th. And what I did is on the bottom, right here, I put together a little movie of the motion of the comet over about a 3-hour period on that same day. You'll see it move relative to the stars when I click on it. So if I click on it now, see if it works there. Look how it moves in the sky. It's moving against the background. I'll click on it again. Maybe I'll get it to move again. There you go. See that? See the way it moves against the sky? I put about 89 pictures there together to show you a little motion. And just about a week ago, on April 11th, another astronomer, okay, in somewhere in Europe, photographed the comet. And as you can see, the comet is already breaking up. You can see right here. Here is the head, okay, or the coma of the comet. And as you look really closely, you can see 3 or 4 different pieces. The comet is starting to break up. So we all get disappointed now. We're not going to probably see a bright comet because the comet is breaking up. So that's the latest in the news. And just as I told you, just about a few days ago, reports that the comet is breaking apart and not going to be as visible as we thought it would be, if at all. It's probably just going to fizzle out. And typically, a large percentage of the comets, as they come close to the sun, this is what happens. They'll break up, and we don't really get to see their full effect. Okay, this is a typical thing that happens, so it's not to be unexpected that this happened to this comet. So that's Comet Atlas. Okay, that's visible in the nighttime sky. I'm going to still see if I can. I've been trying to wait till it gets clear in the next couple of nights to see if it's in a position where I can try to photograph it, to see if I can see the little breakup here. As you can see here, that this guy was able to photograph very well. You can see it looks like 3 or maybe even 4 if you look close enough pieces right here. So That's what happens to comets. As they come close to the sun, they sometimes can burn up and completely disintegrate if they're not packed together well. Here's a photograph, interesting, back in 2006, comet McNaught. McNaught, I guess, obviously is the discoverer of the comet, but this one had a huge tail visible at sunset. Look at this beautiful thing. This was only visible to people in the southern hemisphere. We weren't able to see this. It was not in the sky, visible for us here in the northern hemisphere, but in the southern hemisphere. This was a beautiful sight, this comet McNaught. Sorry about that. The tail of the comet is points always away from the sun, because as these particles are streaming from the sun, they actually push the tail back. So you can see as a comet starts rounding the sun, what you're going to see here is both the ion tail, which is that straight one, the straight one here, and here's the dust tail starting to form. If a comet has two of those tails, they all will point away from the sun. So you can always tell where the sun is because the tail is always opposite to where the sun is. So if the tail is back here, you know the sun is in this direction. So the dust tail always points away from the sun, okay, and so tails will always point away from the sun. And as I told you before, they can disintegrate, okay, when passing around the sun, or even they can collide with the sun. Okay, are they going to do any damage to the sun? Of course not. They're tiny compared to the sun. The sun is just going to eat them up. It's less than even a ping pong ball bouncing off a bowling ball or something like that. So it's really nothing. But also comets can be what we call periodic comets, or they can be non-periodic. That is, they can occur, they can come around every so many years, okay, or sometimes they may just pass one time around the sun, okay. And let's talk about for a moment one of the most famous of all the comets, whether I don't know if you know about it or not, and that's called Comet Halley. It was discovered, it wasn't discovered, but it was named after a friend of Sir Isaac Newton's by the name of Edmund Halley. And it turned out that there were comets that were seen in the year, and I have them listed down here below, in the year 1531, 1607, 1683. And Edmund Halley had looked at some of the reports of that and was working with Sir Isaac Newton on his mathematics, and they were calculating what the orbit of those comets were. And they found that the orbit of the comet of 1531, of 1607, and in 1683 were the same. It was the same orbit. So Edmund Halley said, this is the same comet coming back again. It's some sort of a periodic comet. And Halley predicted, if you look at the difference between the years, between when we saw that, it looks like this comet returned every 76 years. So he predicted that the comet would return in 1758. Now, Halley didn't live until 1758. He died before that time. But when the comet appeared, they named it after Edmund Halley because he had predicted that it would return. And one of some of the earliest type of observations of Halley's comet, since this looks like it's a periodic comet, are one back even from the Chinese. Okay, in Chinese records in 466 BC, that this comet was still visiting the Earth at those times. So this is a comet. The last time it came into the sun and passed close to the Earth was in 1986. I remember trying to photograph it, and I didn't have any pictures. I remember I took a couple of pictures. Wasn't very impressive. But the reason it's so popular is because in one of the returns of Halley's comet in 1910, the comet was going to come extremely close to the Earth. And in fact, scientists had predicted that perhaps the comet may even hit the Earth, or at least that the Earth would pass through the tail of Halley's Comet. And that's the reason you may have heard about it, is because it was a very bright comet in 1910 because it was very close to the Earth. And one of the things people started thinking about is, wondering it's going to be great to see a comet, but remember, as I told you before, the comets put out all these poisonous gases near it, the cyanogen, which is a poison. And they figured, oh my God, is everybody on the Earth going to be poisoned as the Earth passes through the tail of this comet? So people at the time were selling comet pills. Here's an ad for comet pills from the newspapers around the 1910s. Okay, here's articles that people were afraid of the comet coming because maybe it would cause some destruction on the Earth. Maybe everybody will die. So people were taking comet pills. People were buying gas masks so they wouldn't be killed by the comet. In fact, one of my students was telling me that his grandfather still had comet pills in his medicine cabinet, that thinking that the comet pills were actually going to cure him from breathing in this material as the Earth passed through the tail of Halley's Comet. You can see some of the articles and some of the things I found from some of the old newspapers there. Well, it turned out in 1910 the comet was extremely bright because it was very, very close to the Earth. However, the tail was so diffuse that nobody got hurt. There's so little material that's over there that really didn't do any damage, didn't kill anybody or anything like that. But people didn't know that. But this is why Halley's Comet is so famous, because of its what we call its apparition, or the time it appeared in the sky in 1910. In 1986, when it came around 76 years later, as I told you, I was getting excited. I was younger too, and I said, oh wow, it's going to be bright. It was very far from the Earth, so it wasn't very bright. It was really nothing. It was a nothing comet. Some of those other pictures that I showed you earlier were a lot better than the pictures I had taken of Halley's Comet, because Halley's Comet was so far away from the Earth it really wasn't very bright. So it's going to come around again in 76 years after 1986, so that's around 2052, I believe, or something like that. Halley's Comet will come around. Maybe you guys will see it then, and you'll remember, yeah, I remember I took an astronomy course and they told me that it's going to come back. But Halley's Comet is a periodic comet that comes back every 76 years. So, and this is when it became famous, because of that close passage to the Earth in 1910. I want to talk about here is also another reservoir, if you will, of comets that was recently discovered. And in around the year 1950, a Dutch astronomer by the name of Jan Oort, O-O-R-T, found evidence for another structure in the solar system, which we now call the Oort cloud. We call the Oort cloud after Jan Oort. And this is not a belt of material the way the Kuiper belt is outside of the orbit of Neptune that holds all the comets. This is a spherical distribution of material. You can see here it completely surrounds the solar system. It's not a belt of material. If you look right here, this is the Kuiper belt. Okay, this area right here is called the Oort cloud. This also is a area in which it's very cold because it's extremely far from the sun. It may extend to a distance, it starts perhaps at a distance of 5,000 astronomical units. And just to give you an example, remember, Neptune, the furthest planet, is 30 astronomical units. So this is a huge structure. This is the largest structure in the solar system, is this thing called the Oort cloud. And it has a lot of frozen bodies in here. And it's another reservoir, if you will, for comets. So there's some comets that live, frozen bodies that live in the Kuiper belt, and some live out in this Oort cloud. And it's different that it's not a belt, and it completely surrounds our solar system. And it can extend out to almost a light year or more. So this Oort cloud, and a good thing to remember, is it's the largest structure in our solar system. And it's also another reservoir, if you will, of comets. Okay? They are above the sun, below the sun, above the ecliptic. That's the plane of plane of our solar system. They're above and below the ecliptic. And so this is this other reservoir of comets. You can see here's another diagram showing you the Oort cloud as compared to the Kuiper belt. You can see here's the Kuiper belt here, right in the center. You can see here's an exploded diagram showing here's the orbit of the planets. The Kuiper belt is right outside the orbit of Neptune, the largest planet. And the Oort cloud is so much larger structure, completely surrounding the solar system. And so it's the largest structure, also another source of comets coming into the sun. Okay, and I want you to understand that it looks like there are comets, I told you, that are periodic. And by meaning what they're periodic, we can say periodic means their orbits have periods of about 200 years or less. Halley's Comet is one of the famous periodic comets. It comes around every 76 years. Okay, and typically, because usually periodic comets mostly originate from the Kuiper belt. They stay in the Kuiper belt. So typically the orbit of the comet is typically going to be in the plane of the ecliptic because they come from the Kuiper belt. However, there's this other category of comets called non-periodic. And sometimes they may come from either outside our solar system or even within our solar system, and they have orbits of 200 years or more, or they'll never come back. And scientists now understand what the source of these comets is. They figured, what is it that's making comets come in, and if you look at the diagram here, with a very large angle relative to the ecliptic. The ecliptic is this blue disk that you see right here. The orbit of the comet, say, gee, where could these comets have come from if they're coming from above and below the solar system? And the answer is they're coming from the Oort cloud. So typically, non-periodic comets are usually the ones that make very high angles relative to the ecliptic plane, and therefore we can kind of support the existence of an Oort cloud, or a spherical cloud of material that's surrounding our solar system. So periodic comets, as I told you, mostly will originate within the Kuiper belt, and therefore they stay in the orbit of in the plane of the ecliptic and can come back. There's some comets that come back every 2 or 3 years. Okay, they may not be very bright. We don't see them. They don't come close to the Earth. There's some that I told you the most famous of all is Halley's with a 76-year period. But there was just recently a comet, just a few weeks ago, in fact, that looks like it originated from somewhere else in the solar, came from another place outside of our solar system. We can look at its orbit. Okay, it either came from the Oort cloud or somewhere different. Okay, and scientists were tracking it. Forgot the name it was called. It was a Russian name of a guy who started with a B that found it. But it could have been from the Oort cloud or from another area, another solar system. So that's the story about comets and comet orbits. Let's look also, you've heard the term meteor showers, okay? And what I want to explain to you is, what is a meteor shower? And usually meteor showers are associated with comets, okay? Meteor showers result from the debris left over when a comet breaks up, all right? As a comet comes into the inner solar system from the outer solar system, or from the Kuiper belt, or from the Oort cloud, it always leaves a trail of debris in its path. You can see right here. It's going to leave like breadcrumbs, right? It's melting all this stuff. It leaves stuff in its path. And this material that's in its orbit remains in space, okay? There's nothing to move it. It just stays there. Sometimes it moves with a little speed, depending on how much the comet was moving. It may just slow up and stay suspended in space.
And if the Earth would travel through that debris, this debris would enter the Earth's atmosphere and cause what we call a meteor shower. So many times you'll hear about a meteor shower, and meteor showers are actually very predictable because we know where the Earth is in its orbit around the sun all the time, and we know what the position of some of these trails of debris left behind by old comets. There are hundreds of comets and thousands that have come into the inner solar system and left paths of debris, and as the Earth moves through that path, these little pieces of debris, probably the size of grains of sand, enter the Earth's atmosphere and burn up. And you see these little meteors, we'll see, and we see the meteor shower. Let me show you here. You can see, first of all, let me make sure you understand. Here's, you can see the debris left behind by a comet, and as the Earth travels through the path of the debris, we're going to get a meteor shower. And here is a table showing most of the major meteor showers over the course of the year. We know, as I told you, we know where the Earth is going to be, and we know the position of some of these clouds of debris left behind by comets. So here's a table showing the times of the year when we get different meteor showers. Meteor showers are typically named by the direction in which they are coming from, where they seem to be coming from, and I'll explain what that is in just a moment. Usually they come, when we look up in the sky, they seem to come from a certain constellation based on where they are in space and what time of year it is. So you can see here the names of the meteor showers usually have names of constellations. This is called the Lyrid meteor shower because it's in the constellation Lyra. And you can see this is the next one. Here's around April 21st, the Earth is going to be in a position where it seems like there's going to be a lot of these shooting stars coming from the constellation Lyra at roughly about 10 of these per hour. Now, some of these will be very faint. They probably won't be visible from New York City or areas of heavy light pollution. But if you were out in a very dark sky, you may see up to 10 of these meteors an hour, and you can see what's the parent comet. Where did they come from? There was a comet Thatcher. Okay, Comet Thatcher comes around, and that's the debris left behind by Comet Thatcher. A couple of weeks later, the Earth is going to travel through another debris left behind actually by one of the visitations of Halley's Comet. And on May 4th, we're going to, if you look towards the constellation of Aquarius, all right, you'll see that there'll be almost 20 meteors per hour. So here's a list you can see of all the times during the year. You can see all the different times of year when we can expect to see a meteor shower based on the position of the Earth, and we know as it moves through the debris left behind by comets. And you can see here I have a list of which comets have caused these type of meteor showers. I want to explain for a moment to you to understand, I think with a picture, why we get the name of the meteor shower. The name is also called the radiant. It seems to be where the meteors are coming from. Okay, and if you look at, here's a really dramatic picture that I just got about a year ago. I saw that somebody had taken of a meteor shower, and you can see here this is a meteor shower in the evening. This was in a place in northeastern China. This was called the Geminid meteor shower because, as you can see, all the meteors seem to trace back. If you trace their path, they all come from an area of the sky right here. And this area of the sky here, you can see two bright stars right here. Those two bright stars are the stars Castor and Pollux that are in the Gemini constellation. So it looks like this radiant, this meteor shower is emanating from the Gemini, the constellation Gemini, and therefore we call it the Geminid meteor shower. Okay, so the radiant of a meteor shower is the place in space, the constellation that meteors seem to be originating from. And I say seem to be originating from because I want to explain something. All of these meteors are coming in parallel paths towards us. Think of looking at a set of railroad tracks. You know that the tracks are separated by a certain number of feet, whatever that is, 6 feet or whatever it is. And we know if you look at a railroad track at a distance, it looks like the tracks will actually get closer to one another as you get further from where you're looking. Okay, you can see it looks like they get, even though we know that they're parallel, because in the distance it looks like they're getting closer together. And that's exactly the same effect that you see here. Because they're further away, they look like they're getting closer together, but they're actually coming in at a parallel path. So it just happens to be, as the Earth is rotating, what position where you live, okay, and what position, where the sky, what the sky is like, where is the Earth in its orbit around the sun, what constellations are going to be in the sky at night, and wherever those meteors seem to be coming from is what we call the radiant. The radiant is the area in space, the constellation that meteors seem to originate from. That's what we call the radiant of a meteor shower. Okay, so I wanted to get through this material today. There's probably one more lecture that we're going to talk about in the chapter on the solar system before we have an exam. So we'll probably have an exam next week. Okay, probably on Thursday of next week, the day the writing assignment is due. I'll probably give you an online exam on this chapter, so be prepared. This is lecture that I just gave you here is the lecture for Thursday of this week, and next on Tuesday I'll give you the last lecture for that chapter, and on Thursday I'll follow it up with an exam. So be prepared Thursday. Don't wait. Please don't wait to do your paper at the last minute, because you also have to study for the exam. So we'll have an exam. It'll consist of questions just like you saw before, always true and false, fill in the blank, multiple choice essays, again, on this chapter on the solar system. So until next Tuesday, I bid you farewell. I hope everybody remains safe, and hopefully we can see each other somehow soon. Bye.